So we're going to watch this video here and we're going to see how the Himalayan mountains form. So I'll play this animation and I'm going to read up here. So observe an animation of the Himalayas forming. So this simulation shows how the Indian plate moving north as the oceanic crust on its leading edge subducts beneath Eurasia. So up here's Eurasia and here's the Indian plate. Subducted material erupts from volcanoes on the Eurasian plate. And as the sea closes, the continents collide because continental crust cannot be subducted. The Himalayas form from oceanic sediments and rocks crumpled in the collision. And you can see them kind of crumpling in here, in this area right here. India is fused to the Eurasian plate. Its northward motion continues today, pushing the Himalayas even higher. Let's watch it one more time. So we have the Indian plate colliding with Eurasia. Pieces of it get scraped off. It builds up. This is your Tibetan plateau. Here are the Himalayan mountains. And here's India. It's still being driven into this. This is into Eurasia. This is what we call a collisional boundary where continental crust is colliding with continental crust. So here we can view a picture and we can have this kind of time lapse with the geologic timeline. So 70 million years ago, India was a landmass that was but was kind of moving along, connected to oceanic crust, continued to move northward toward Eurasia, and Eurasia's got a relative movement southward. And 50 million years ago, it's at this location, roughly at the equator. And here we have the collision of the Indian plate today with Eurasia. It's literally fused onto the Eurasian plate, and the Himalayan mountains and the Tibetan plateau are still currently growing today. So here's a cross-section of the Indian plate colliding with the Eurasian plate. And notice we have this very distinctive line of sediment that gets, or this rock here that gets scraped off as this old plate subducted. India is still moving northward into Eurasia. So these this entire mountain range, the Himalayan mountains at this boundary, continue to grow greater than the rate of erosion. So in other words, there's a net upward movement. So they'll grow to a certain height until they either reach equilibrium or begin to erode altogether faster than they're rising. So here's what we have. We have the continents that are colliding here, a collisional boundary. There's only one place for the low density felsic rock to go, and that's rise vertically.